Combined gas law is when you have a fixed mass of gas or number of moles. Now pressure and volume and temperature describe the gas, so it's N times R. And I'm saying if N is fixed, if you change the condition of temperature or pressure or volume or all of them, they relate to each other as P2V2 over T2. But since number of moles is not changing and R is gas constant, this equation, just like dilution problem, becomes really nice and really useful. P1V1 over T1 equals P2V2 over T2. Subscript 2 is describing later time, or after subscript 1 is before any changes that you are introduced to that gas. So for first question is, if you have 200 centimeter cube of a gas and it's heated from 50 degrees Celsius to 100 at constant pressure, what's your new volume? Now, one thing you should notice now is if the pressure is in Pascal, kilopascal, or any other unit, and volume is centimeter cube, decimeter cube, both sides can be the same, but temperature has to be converted to Kelvin. This is our mistake that I see number of times by students, especially if they have multiple choice. They just want to solve it, they know their chemistry, and they forget on this little detail of conversion of temperature. So I go to the combined gas law, P1V1 over T1 equals P2V2 over T2. It's given to be constant pressure, meaning that pressure 1 is same as pressure 2. So what happens when you plug it in? The pressures go away, so volume 1 over temperature 1 is equal to volume 2 over temperature 2. I'm solving for V2, so when you play with variables, V2 is nothing but V1 multiplied by T2 over T1. And it makes sense. If temperature goes up, the volume supposedly has to go up. So we are going to plug in. So volume 2 is equal to the first volume, 200 centimeter cube. I'm not changing it into decimeter cube. I don't need to because my final answer becomes in centimeter cube. Now temperature 2, if you put 100 over 50, which majority of us do, then you say, oh, volume 2 is 400 centimeter cube. That's our first mistake. Please don't do that. Convert it to Kelvin. So temperature 2 is, I'm going to add 273 plus this, which is about 373. And this one plus 273 becomes 323 Kelvin. It's no more a factor of 2, so 373 new temperature, higher temperature divided by 323 Kelvin. They go away, and this is a factor of 1.15, so your final answer is 231 centimeter cube. So this is your new volume at a constant pressure when temperature has become doubled in Celsius, but not necessarily true in Kelvin. It's not doubled. So please convert to Kelvin, otherwise you make mistakes. Now let's solve another problem. Now this problem was given in November of 2002. A balloon which can hold maximum of 1100 centimeter cube of air before bursting contains 955 at 5 degrees Celsius. Determine if the balloon is going to burst as temperature has increased to 25. Assume the pressures are held constant, like the problem before. P1V1 over T1 equals P2V2 over T2. Pressures are the same, so they cancel each other out. And since we are solving for volume, so V2 is nothing but V1 times T2 over T1. Then again, if you don't convert it to Kelvin, you will get the wrong answer. So the first volume is already what I have in the balloon, which is 955 centimeter cube, multiplied temperature 2 plus 273, so this is 298 Kelvin. Temperature 1 was 5 degrees Celsius, which is 278 Kelvin. So 298 K for Kelvin divided by 278 K, and if you calculate, you will come to the answer of 1024 centimeter cube. Now the question is, would the balloon burst or not? 1024 centimeter cube is less than threshold volume, which is 1100 centimeter cube. Therefore, the answer is no, the balloon will not burst. Okay, then again, majority of students do not convert their units of temperature, and they have another answer and they get partial credit. Now it's also important, pay attention to the marking. So this is 3-pointer, and they give you 1 point for the appropriate equation, 1 point for exact answer and your judgment. If your answer is wrong and you still make a judgment as the balloon burst, for example, you still get partial credit, but try to get all your points. Now, I have a couple of multiple choice questions at this stage, so let's see what happens. You have 3 decimeter cube of sulfur dioxide, so 3 decimeter cube, and you have 2 decimeter cube of oxygen, and the question is how many decimeter cube of sulfur trioxide you produce. Now, one thing I want you to remember again is number of moles is proportional to volume. Not exactly the same. Remember, at STP, 1 mole is 22.4 decimeter cube. But this is good because what it gives me a chance to ignore decimeter cube, and instead of that, imagine I have 3 moles of this and 2 moles of this. And if I find my number of moles here for sulfur trioxide, all I have to do is, for multiple choice, get rid of moles and answer them in dm cube. So this becomes a limiting excess question. Divide both sides by their coefficient, 2 versus 1. This will give you 1.5, which is less than 2. Therefore, sulfur dioxide is your limiting. If that's the case, for every 2 moles, you produce 2 moles of sulfur trioxide. For 3 moles, you should definitely produce 3 moles. Since that's just the proportionality, it's 3 decimeter cube, so your answer is C. Now, another question, May of 2003, what will happen to a volume of fixed mass of gas when the pressure and temperature are both doubled? So P1 V1 over T1 equals P2 V2 over T2. Now they say pressure is doubled, so P2 is twice as big as P1, and T2 in Kelvin is twice as big as T1. So instead of P2 and T2, I'm going to produce the older variable. P1 V1 over T1 is equal to 2 P1 times V2 over 2 T1 over 2T1. Sorry. Let's just write it one more time. So this is 2P1 multiplied by V2, and instead of T2, I'm going to put 2 T1s. Now T1 cancel each other out, P1 cancel each other out. So volume 1 is equal to 2 over 2 times volume 2. 2 divided by 2 is 1, so volume 1 is same as volume 2. If you double the pressure and double the temperature in Kelvin, you get exactly the same answer. There is no change in volume. Okay, until next tutorial, next few tutorials, I'm going to give you some old IB questions that has a mixture of stoichiometry, solid, aqueous, and gases. Good luck.